false position method, and let me check my code and run. And my equation is x cubed plus 9 again, and the first initial point is 1, the second one is 3, and the minimum error is the same as before. And the maximum number of iterations, and also 20. Here is figure 3 for errors for each iterations, and the other figure is here. Let me explain my code. Step 1. The user is prompted into an equation in terms of x. This function is used to convert the input equation into a MATLAB function handle f for ladder evaluations. Step 2. Graphical representation. The entered equation is plotted on a graph for visual representation. Hold on allows overlaying additional plots of the same figure. Step 3. User inputs. The user is prompted to provide two initial points x0 and x1, a minimum error for convergence mean error, and the maximum number of iterations max iterations. Step 4. False position iterations. A loop is set up to iterate for a maximum number of iterations specified by the user. Step 5. False position calculations. The false position formula is used to calculate the next approximation for the root x mid. The function value at the midpoint f mid is also computed. Step 6. Interval update. The interval x0 and x1 is updated based on the signs of f mid and fx0. If they have opposite signs, the root lies between x mid and x0. Otherwise, it lies between x mid and x1. Step 7. Iterations details display. Details of each iteration such as x0, x1, x-mid, f-mid, and the error are displayed in a formatted manner. Step 6. Step 8. Graphical representation of estimated root. A red field point plotted on the graph to visually represent the estimated root. Legend is used to display a legend on the graph. Hold off is used to stop overlaying additional plots on the figure. Step 9. Error plot. A new figure is created to display the errors of each iteration. The errors are calculated and plotted against the iteration number. And thank you for listening me.